You are tuned to IRE Learning, and I am your host, Teacher. In this small concept lesson, we will introduce empirical and molecular formula. By the end of this lesson, we should be able to define the terms empirical formula and molecular formula, distinguish between the empirical and molecular formulae, and deduce the molecular and empirical formulae of a compound given the structural formula. Now, the empirical formula, which is often abbreviated EF, is the lowest possible ratio of the elements present within a compound, while the molecular formula, which is abbreviated MF, is the highest possible ratio of the elements present in the compound. It actually tells the exact number of each type of atom present within one molecule of the compound. So let us distinguish between the empirical formula and the molecular formula. Now we will use the molecule glucose to explain how to derive or deduce the empirical and molecular formula of a compound. And we'll start with the molecular formula because the molecular formula tells the exact number of each type of atom within the molecule. So if we were to start with carbon, there are 1, 2, 3, 4, 5, 6 carbons in the formula. So we write C6 because there are 6 carbons, followed by the hydrogens. If we were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbons. So we write H12, followed by the oxygens. There's 1, 2, 3, 4, 5, 6 oxygens. So we have O6. As a result, the molecular formula for glucose would be C6H12O6. Now, the empirical formula, on the other hand, gives the lowest possible ratio that these atoms could exist in. So what we have to do is find out what is the highest common factor between the quantities of each type of atom that exists within a molecule of glucose. And that highest common factor for 6, 12, and 6 would be 6. So we're going to divide through the quantity of each type of atom by its highest common factor of 6. So 6 divided by 6 will leave 1 carbon, 12 divided by 6 leaves 2 hydrogens, and 6 divided by 6 leaves 1 oxygen. So the empirical formula for glucose is CH2O, which represents the lowest possible ratio of all the atoms within a molecule of glucose. Next, we look at a molecule of water. Remember, the chemical name for water is also hydrogen oxide. Now we'll look at the empirical and molecular formulae of water. The molecular formula tells the highest ratio of each type of atom within the molecule of water, or the exact number of each atom within the molecule of water. So as you can see, we have 2 hydrogens and 1 oxygen. So the molecular formula for water is H2O. So there are 2 hydrogens and 1 oxygen atom in a molecule of water. We can now use the molecular formula to deduce the empirical formula for a molecule of water. First, we find the highest common factor between the quantities of hydrogen and oxygen. So that's between 2 and 1. Now, the highest common factor for 2 and 1 would be 1. And as a result, we know any number divided by 1 would give us back that number. So 2 hydrogens divided by 1 would result in 2 hydrogens, and 1 oxygen divided by 1 would give us back 1 oxygen. So in this case, notice that the molecular formula and the empirical formula are the same, H2O. So we'll also note that for some compounds, the molecular and the empirical formula are identical. And this is always a case when the molecular formula cannot be simplified any further. Next, we'll look at a molecule of ethene. Ethene is an organic molecule, and when we get to organic chemistry, we'll learn a little more about the alkenes, of which ethene is a member. So we're going to examine the empirical and the molecular formula. Once again, we'll start with the molecular formula that gives the highest ratio of the atoms within the molecule. And in this case for ethene, we have 2 carbons and 4 hydrogen atoms. So the molecular formula for ethene is C2H4. Now the highest common factor of 2 and 4 would be 2. So we're going to divide through the quantity of each atom by 2 in order to obtain the the empirical formula. So 2 divided by 2 gives us 1 carbon, so we're left with 1 carbon there, and 4 hydrogens divided by 2 would give 2 hydrogens. So the empirical formula, which is the lowest possible ratio of the atoms within the molecule, would be CH2. Now we have another organic compound, which is pentene, and we will examine once again the empirical and the molecular formula. So in pentene, there are 1, 2, 3, 4, 5 carbon atoms and 3, 5, 7, 8, 9, 10 hydrogen atoms. Therefore, the molecular formula for pentene is C5H10. So there are 5 carbons, 10 hydrogens, and the highest common factor of 5 and 10 would be 5. So we're going to divide through each quantity of atom by the highest common factor. So 5 divided by 5 would give us 1 carbon, and 10 divided by 5 would give us 2 hydrogen atoms. As a result, the empirical formula for pentene is CH2, which is identical to the empirical formula for ethene, which is also CH2. As a result, we know that different compounds can also have similar or identical empirical formula. So our lesson summary would include that the empirical formula is the lowest ratio of atoms of the elements in a compound, while the molecular formula gives the number of atoms of each element within a molecule of the compound. Dividing the molecular formula through by its highest common factor gives the empirical formula. The empirical formula is the same as the molecular formula when the molecular formula cannot be simplified any further. Compounds with different molecular formula can have the same empirical formula as we saw with ethene and pentene in the examples done. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. Identify the statement that is true about the empirical formula of a compound. The empirical formula is A. The lowest ratio of atoms of the elements in a compound. B. The empirical formula is the same as the molecular formula. C. The empirical formula is the maximum number of atoms within a molecule. D. None of the above. The answer is A. The empirical formula is the lowest ratio of atoms of the elements in a compound. Question 2. For which organic compound given below is the empirical formula the same as the molecular formula? A. C3H3, B. C6H6, C. C7H8, D. C3H6. The answer is C, C7H8. Notice all the others have a highest common factor that would be greater than 1, with the exception of C. So if we look at the different molecular formulae given in the 4 options, you notice the first one has a common factor of 3 for the quantity of carbon and hydrogen. So we divide through by 3. So 3 divided by 3 gives 1 carbon, and 3 hydrogens divided by 3 gives 1 hydrogen. So the empirical formula CH is not the same as C3H3. For option B, we have the highest common factor here being 6. So we divide through by 6, and 6 carbons divided by 6 gives 1 carbon, and 6 hydrogens divided by 6 gives 1 hydrogen. So once again, we have an empirical formula of CH which is different from C6H6. For option D, there are 3 carbons and 6 hydrogens, which means the highest common factor for 3 and 6 would be 3. So we divide through by the highest common factor of 3. 3 carbons divided by 3 would give us 1 carbon, and 6 hydrogens divided by 3 would give us 2 hydrogens. So here, the empirical formula CH2 is not the same as C3H6. Now for our answer, notice that there is no common factor greater than 1 for 7 and 8. So there's no number greater than 1 that could possibly divide into 7 as well as 8 without leaving a remainder. So our common factor would be 1, which means when we divide each number by 1, we return with 7 carbons and 8 hydrogens. And so in this case, our empirical formula and molecular formula are the same. Question 3. What is the empirical formula of the compound benzene shown to the left of our screen? A. C3H3, B. C6H6, C. CH3, D. CH. The answer is D. CH is the empirical formula for benzene. So here we have the chemical structure of benzene. So we can find the molecular formula. So let's count how many carbons. 1, 2, 3, 4, 5, 6 carbons. And we have 1, 2, 3, 4, 5, 6 hydrogens. So the molecular formula for benzene is C6H6. Notice the highest common factor for 6 and 6 would be 6. So we're going to divide through by 6. And as a result, 6 divided by 6 gives us 1 carbon, and 6 hydrogens divided by 6 gives 1 hydrogen. So we end up with an empirical formula CH. Question 4. Which statement is incorrect about a molecule of glucose? A. The empirical formula of glucose is CH2O. B. The molecular formula of glucose is C6H12O6. C. The empirical formula and molecular formula of glucose are the same. D. The empirical formula and molecular formula of glucose are different. The answer is C. The empirical formula and molecular formula of glucose are the same. That is the incorrect statement. As we know, the molecular formula for glucose is C6H12O6, while its empirical formula is CH2O. Question 5. The molecular formula for pentene is C5H10. What is the empirical formula for pentene? A. C5H10, B. CH5, C. CH, D. CH2. The answer is D. CH2. So for pentene, there are 5 carbons and 10 hydrogens. So as a result, the highest common factor of 5 and 10 would be 5. So we're going to divide through by 5. So 5 carbons divided by 5 gives 1 carbon. 10 hydrogens divided by 5 would give 2 hydrogens. Therefore, the empirical formula of pentene is CH2.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Irie Learning.